go load my videos to YouTube. And so if you go to the playlist, you should see over time more and more videos associated with this course. Okay, and I'd suggest them as a source in case they shed light on anything that's going on. Okay, so I'm going to ask her to call up AnyLogic, and I think many of you have done that already. I have myself. And what we're going to do with this version of AnyLogic is we're going to open up an example model. And we do that in AnyLogic through the help menu here. Okay. So I'd like you to go over to AnyLogic. I'm going to be switching over here myself. And we can go up to help and do example models here. Okay. And when we do that in AnyLogic, I'd like you to look for a model called, in the how-to model section over here on the left, and it's called SIR agent based. That will be visible on the right-hand side of this screen. So in other words, when this screen comes up, this splash screen, there'll be how-to models on the left, you'll select that, and then on the right hand, you'll select SIR agent based. As I am wont, I'm going to go do this myself. You'll note that AnyLogic runs within the Eclipse framework. I believe technically it's an Eclipse RCP application for those who are familiar with that concept. And what that means is, among other things, one of the implications is that it's divided into these tabs. And by double-clicking on the tabs, you can full screen them and sort of focus on that particular tab. And double-clicking again will make it not full screen. Okay, so what we're going to here is the how-to models down here on the left-hand side. In the fullness of time, it will pull up this list over here to the right. And I'd like you to scroll down to this model, which is called SIR agent based. Does anyone in the room know what SIR stands for? Yes? That's right. So it's dividing up the population into 3 categories, okay? So what I'd like you to do is to click on that, and that will load in this model. You'll notice there's diverse other, probably hundreds of example models here. You'll also find on that site that I posted for the class, the Consensus ABM site, I have dozens of additional models. Okay, it says it's already open. Yeah, sure, I'll discard it. So it'll open it here. Now I'll have to ask for your pardon because I have a number of other models open, and so my screen is going to look a little bit different than yours, but you're going to end up seeing something like this once it's open. Okay. And we'll come back to it. So the focus of this model is spatial spread of infectious disease. What I mean by spatial is, it spreads over some space. Now, we talk about infectious diseases in this class for several reasons. One of the reasons is because they're of great domain importance. This is an area of great import, an area which takes a lot of society's resources, where there's a lot of human suffering and fundamental issues of life and death involved. And for many of our students, those things are first and foremost. For those who are interested in this from a more methodological perspective, from a computer science perspective, infectious diseases are one of the most simple, illustrate in some of the most simple fashion some of the features of nonlinearity that demand simulation models. More than that, the processes that describe the behavior of infectious disease translate quite transparently in many cases over to other domains, other areas of discourse. For example, the spread of ideas, the spread of attitudes, beliefs, the spread of rumors. These are described by infectious disease. Seth has kindly delivered a set of laptops here. Would anyone like a laptop with AnyLogic running on it here?
Just for
Okay.
right now.
Thank you for the clarification, Seth. We'd get a very quickly larger class if it were otherwise. Okay, so in this case, we're simulating the spread of infectious disease in a regular space. And the simulation is going to start with a single, what we call an index infective, an initial infective, okay? So I'm going to go down and open up this model. It's the lowest one here. And I'm going to go double click on person here, okay? And what you'll see is, and I'm going to actually rearrange my screen to use the screen real estate afforded to us a little bit more efficiently. So I'm pulling these tabs around in a way that you folks, of which you folks might also want to avail yourselves, okay? And that actually resisted my attempts here. Okay, let's try that again. There we go. Okay, good. Okay, so I just double-clicked on person. You'll notice over in the left-hand side we have a model, and the model is composed of several pieces. There's a main, so-called main class, which is going to be a depiction of an environment and, as it were, the stage on which agents are going to strut. And then there's a set of agents, and one of them is called person. And this class, the so-called class, is going to define personhood or personness as far as the model is concerned. Ladies and gentlemen, all models, in addition to being theories, like theories, they're abstractions. They address certain things, and they leave out a lot of details. And that's their power. Why do I say that? Why do I say that's their power? A bit of a digression, but an important one. Ladies and gentlemen, you can think of models like maps. In fact, this is worthy of nuggetation. So pardon me as I